Good morning, all of you, and let's see this problem. And it's more kind of research work than just solving this problem over here. So suppose that for every integers n greater than equal to 2, we have hn as the set vn by x2 to xn, so set of n minus 1 tuplets of whole number. N0 means it's like natural number union 0. So that's how you define n0 as a set of all whole number. We have to find the sigma of all elements belonging to Hn and this summation. So let's call this as Dn. Right, now it's not very easy to solve this sum in a closed form as of now immediately just by looking at the problem. And the JES strategy of solving this problem will be to the set will stop. So let's try with S2 first. So H2 is gonna give me only one element S2 such that 2x2 is equals 2. So put n equals 2 everywhere so that x2 is a natural number, so that x2 is a whole number. So the only element in this set is x2 equal to 1. So if I'll find this d1 value, so it's nothing but sigma x2 equal to 1. That's the only member from the set. N factorial 2 factorial by 2 raised to the power x2, so 2 raised to the power 1 into x2 factorial over here, so which gives me 1 factorial. So the answer for this is 1. Let's try S3 now. So that will be the set of x2 comma x3 such that 2x2 plus 3x3 is going to give me 3. And now the solutions from this will be x2 equals 0, x3 equals 1. If I take x2 equals 1, x3 is not possible. Similarly, x2 equals 2, x3 is not possible. So the only solution is x2 0, x3 3. And that will give d3 as summation of x2 0 and x3 1. That's the only element from the set. So we'll have 3 factorial divided by, if I take the first term x2 0, so it's 2 to the power 0, 3 raised to the power 1 times 0 factorial into 1 factorial. And since I have only one term, so this d3 is going to be just single summation. And we can see this is 2 to the power 0 1, 0 factorial is 1 by definition. So here we got the answer is 2. It's better to try one more to get a feel of some pattern if at all it's coming. So for d4 we'll calculate first h4 set. This is x2, x3 and x4 such that 2x2 plus 3x3 plus 4x4 is going to give me 4. And let's calculate how many elements are there. So let's start with x2 equals 0. So we need 3x3 plus 4x4 equals 4. So that's only possible if x3 is 0 and x4 is 1. So x2 0 will give me, x3 0 will give me 1 pair. Now what if I take x2 as 1? So x2 equals 1 will give me 3x3 plus 4x4 equals 2. Now that's not possible. So let's try the next value of x2 as 2. And x2 2 works because that will give me 4 plus 3 times I can set others to be 0 and 0. So x2 2 will give x3 0 and so is x4. Right? And what about if x2 is more than 2? So that's anyway not possible, so 0. So here we got replace 0 0 1 and 2 0 0. So if I'll keep in that summation, we have 4 factorial divided by 3 raised to the power 2 raised to the power 0, right, into 3 raised to the power 0 into 4 raised to the power 1 into 0 factorial 1 factorial plus 4 factorial divided by 2 raised to the power 2 to 3 raised to the power 0 into 4 power 0 into 2 factorial into 0 factorial into 0 factorial. And this summation gives me this guy is 1, so it's 4 factorial by 4, which is 6 over here, and we have 4 into 8, right? So 4 factorial can be written as 24, so 8 3 is 24, so we have 6 plus 3 equals 9. Now you must be suspicious about these values. You must be suspicious about these values, and that's literally crazy. Well, correct, you got it correct. This is rearrangement. So it fills, because if you see D1 I'm getting 1, D2 as well, I've tried with n greater than 2, so D2 we are getting as 1, and D3 value is 2. D4 we got 9, and if you calculate for D5 you're going to get 44. So this summation Dn represents rearrangement of an object, which can be independently proven from the principle of inclusion and exclusion. So now from here, one way to prove is using principle of mathematical induction. That's also not too settled over here. It's a little bit technical, but it can be done now. But for our JEE purpose, once you recognize this pattern, well, you can feel that these forms rearrangement. And what is interesting is, like, in fact, in this formula of Dn will be exactly same as our well-known rearrangement formula. And what is well-known rearrangement formula? That goes to sigma of n factorial times sigma minus 1 to the power k by k factorial, and k is running into 2 to n. And this I have already proved in one of my video by many method. One is by principle of inclusion exclusion, and other is by the recursion. Well, so this is a typical rearrangement formula Dn, and for the first time you are seeing that rearrangement formula can be posed in this beautiful fashion, and that's literally crazy. And what is interesting is the case when n will tends to infinity. Under that case, this will be having n connection, right? So it will be having e connection. So it will be related with e because it will be series expansion of e. So even this quantity, when hn is tending to infinity, like ordered pair when n is too large, we converge to e value. Like the fraction of arrangement which got dearranged is basically n factorial by e when n is almost by 1 by e factor, which is quite close to 1/3, little bit less than that of the total objects in arrangement of n objects will be dearranged, destroyed arrangement, like none of the object will be in its original configuration. So the theme of today's polynomial was especially for your objective kind of examination, pattern making is very crucial. Okay, it's very important because that also shows you have understood the question properly, and once you find pattern, it's going to fetch you good amount of deal in problem solving, because you might be able to relate the ideas and the stuffs which is already there within your syllabus. So since rearrangement is in our JEE advanced syllabus as well as mains, so possibly if they give these questions and ask you find D5, so one way you can directly plug D5 and using case making this summation can be found, but probably better way will be to start with the induction of 2, 3, 4, and then having suspected that we can go with those values. So if you are enjoying these lectures and if you feel like this is adding to your thought process and ideas of problem solving, please do like and subscribe. By the way, this problem can be directly solved using group theory, which I'm not going over here because I'll come with a separate college algebra courses where I'll deal with group theory and probabilistic theory from a different perspective.